Okay, so number one is asking us to find the radian measure of negative 100 degrees. So we use our formula and we write negative 100 times pi over 180 degrees. And so these degree symbols are going to cancel out. So then we're going to have 100 pi, negative 100 pi over 180. And then that's going to simplify down to negative 10 over 18. And it's going to simplify again down to negative 5 pi over 9. So it's going to be our final radian measure. The next one is asking us to go from radians to degrees. So we're going to do 5.9, and it's going to be the opposite formula. So we're going to multiply it by pi over 180 degrees. And putting that into our calculator, we get approximately 338.045 with some remaining decimals, and it's asking us to round to the nearest degree, so we're going to round down to 338 degrees. Part A is asking us to find an angle between 0 degrees and 360 degrees that is coterminal with negative 900 degrees. And so what we do is we're going to add or subtract 360 multiple times to find that same angle. Remember, because if we have the unit circle and we have some angle here, right, this angle plus 360, right, is going to loop us right back around to that same angle. That's how we're going to find that coterminal angle. So to do that, we need to think about how many times should we add 360 to make it in between 0 and 360. So we know that 300 times 3 is 900, so let's think about adding 360 times 3. So we have negative 900, and we're going to add 360 times 3, so we get negative 900 degrees plus 1080 degrees, which is going to end up getting us 180 degrees. So then that angle is between 0 and 360. So that checks, so this is going to be our final answer. Kind of doing the same thing as the last problem, we want to take our original angle, 9 pi over 7, and we want to add or subtract 2 pi to get to an angle that's the same, because we're going around that unit circle. So we're going to add 2 pi first, and we need to multiply this by 7 over 7, which is just multiplying it by 1, so we can add these fractions. So once we do that, if we simplify that down, we end up getting 5 pi over 7, which is in between 0 and 2 pi, which gives us our first one. And then we can subtract 2 pi. It's also going to give us the same way. We're just going in a different direction. So we're going to minus 2 pi, and we still need to multiply it by 7 over 7, so we can add those fractions. And that is going to give us negative 23 pi over 7, which is not in between 0 and 2 pi, but we only needed one of those angles to be in between 0 and 2 pi. So these are our two answers. Also, you don't have to subtract 2 pi. You could add 2 pi to your original 5 pi over 7. You could add 2 pi, again, times 7 over 7, and this would give us another answer, 19 pi over 7, which is equivalent to all these angles. Either way works. Okay, so it's asking us to find the distance from A to B. So to do this, we need to use two formulas. One is going to be our arc length formula, which is S equals R theta. And R would be A to B, that would be our radius. And so we know that our arc length is 50 feet. So we know 50 equals R theta, but we don't know theta. So we can solve for it though. Say divided by R, we have 50 over R equals theta. And another equation we have is we know that the area is 1,500. So we can use our area formula. We can say 1,500 is equal to 1/2 R squared times theta. And we have a formula for theta here, so we can put that in and we can say 1,500 is equal to 1/2 R squared times 50 over R. And we know those R's are going to cancel out, so we won't have that R on the bottom. So then we have 1,500 equals 1/2 times r times 50, which we can simplify that 50 and that 1/2, and we can say 1500 is equal to 25 times r. And then once we divide by 25, we get r is equal to 60 feet. So it's asking us what is the measure of angle A in both degrees and radians. So remember we have our arc length formula, S equals r theta, and we know S and we know r. Remember S is 50, and we just found r to be 60 times theta. If we solve, we get 50 over 60 equals theta, or 5 over 6 equals theta. And remember, for arc length, our angle is always in radians, so this is the answer in radians, but we need to change that to degrees because we need them both. So we need to multiply 5 over 6 times 180 over pi. Putting that into our calculator, we get approximately 47.746. Rounding, we get 47.7 degrees. So this is our angle in radians, and this is our angle in degrees. So it's asking us to find the largest value of sine of each of these angles. So remember that sine of each of these angles is going to be the y-coordinate for each of these points corresponding to each angle. And so to check to see which one is the largest, we want to kind of drop a horizontal line to the y-axis, and we want to see where each of these hit. So this one's going to be right about here. We can see that B is a little bit lower. C is going to be way down here. D is right about here. F is almost the same, and E is way down here. So our max value, or largest value, is going to be this A because it's the highest on our y-axis. So sine of A is going to be our largest value. And our smallest value is going to drop all the way down here at E. We see that's our lowest on our y-axis, so it's going to be our least value. So sine of E is going to be our smallest value of sine. So now we're doing the same thing but with cosine. So if sine was y, cosine is going to be x. So then we want to do the same thing, except we're going to drop these lines to the x-axis instead of the y-axis. We're going to drop this vertical line here. We can do this one here. And then B is sitting right about here. E is here. A is right about here. And F would be right here. So our furthest value to the right is going to be F, which is going to be our largest value of cosine because that's our x value. So cosine of F is our largest, and then our smallest is going to be C because they're furthest left on our x-axis. So the smallest would be cosine of C. Okay, so it's asking us to name the quadrant in which negative 11 pi over 9 lies, and then find its reference angle. So first, to find the quadrant, we need to find the coterminal angle, which, remember from earlier, we're going to have 11 pi over 9, and we're going to add 2 pi, and then remember we have to multiply by 9 over 9, so we can add these fractions. Just putting this into our calculator, we end up getting 7 pi over 9. So that's going to be, if we draw kind of a unit circle, that is going to be somewhere over here, right? Because like 4.5 pi over 9 would be like right here on that y-axis. And so this is going to be 7 pi over 9. And so finding that reference angle, remember it's going to be how close is it to our x-axis. So this would be 9 pi over 9, so our reference angle would be 2 pi over 9. So step 1 is saying we are lying in quadrant 2, and our ref angle is 2 pi over 9. Okay, to find two different angles that lie in quadrant 2 that have a reference angle of 3 pi over 13. So step 1 is to kind of understand what it's asking us. So we want an angle that lies in somewhere in the second quadrant. When this is 13 pi over 13, this distance here, this angle right there, is going to be 3 pi over 13. How we can do that is we're just going to subtract 3 pi over 13 from 13 pi over 13, which is going to leave us with 10 pi over 13. So that's one of our angles. And then another one of those angles is if we find a coterminal angle equal to this angle. So how we do that, remember, is we're going to add 2 pi. So we have 10 pi over 13 plus 2 pi. And remember, we have to multiply it by 13 over 13. So we can add those fractions, and that is going to equal 36 pi over 13. You can also do this by subtracting 2 pi, and that would leave us with negative 16 pi over 13 if we subtracted 2 pi instead of adding 2 pi. Okay, so it's asking us if sine of theta is greater than 0 and cosine of theta is less than 0, in which quadrant does the angle theta lie? So remember, sine of theta is equal to our y-coordinate where our angle meets the circle. So if sine of theta is greater than 0, that means sine of theta is positive. So that could be either in this quadrant or this quadrant, because our y-axis is positive there. And then we know that cosine is our x-coordinate on the circle. So to find when cosine is less than 0, that's when cosine is negative. So that's either going to be this quadrant, cosine of theta, or this quadrant, because that's when our x-axis has negative values. So for both those things to happen, we're going to be in this second quadrant here. So that would be quadrant 2.
Okay, so looking at number 9a here, we want to find the exact value of each of the following. So we want to find what tangent of 5 pi over 6 is, right? So we want to think about our unit circle. I'm going to go over here, and 5 pi over 6 is in our second quadrant over here. So I'm going to draw an arrow. And we're looking at tangent, right? So tangent is equal to y over x. So our y value for tangent of 5 pi over 6 is 1/2. And our x value is that negative square root of 3 over 2, right? So that 2 and 2 go away. So tangent of 5 pi over 6 is equal to negative 1 over square root of 3, or another way to write that is going to be the negative square root of 3 over 3. Right, now looking at part B, you want to know what cosecant of negative 2 pi over 3 is. Another way we could write this is 1 over sine negative 2 pi over 3. So we know this is going to end up being 1 over our y value. So we have this negative 2 pi over 3 there. So we need to find the coterminal angle. So what we're going to do to find our coterminal is take negative 2 pi over 3, and we're going to add 2 pi to that, and we're going to be left with 4 pi over 3. So really what we want to find is what 1 over sine of 4 pi over 3 is. So 4 pi over 3 happens right here on our graph. So we're going to go over, around, right here. And we want 1 over the y value. So the y value is negative square root 3 over 2. So negative square root 2. Now we're going to write this just in a nicer way of negative 2 over square root 3. Or just another way to write that is going to be negative 2 square root 3 over 3. Now looking at number 10 here, suppose that point A, B lies on the terminal side of angle theta in quadrant 2. What is the value of sine theta? So, sine theta is equal to our y value, right? So We write out our coordinates, x and y, so we know sine theta, in this case, is going to be equal to b. Right? So next we want to look at what sine theta plus pi is, right? So we need to add pi to this theta, and it's going to put us in this fourth quadrant over here, making our a positive and our b negative. So we want to know what sine of our new value is, which is going to be our y value there, so we're just going to be negative b. And then next we want to look at what the value of cosine, right? Cosine of theta plus pi. I'm just going to leave that drawing there. And we know cosine of theta plus pi. You know, that means we want the x value, right? So in this case, it's just going to be a. Alright, so looking at number 11 now, we want to find the missing side lengths x and y and the missing angle theta in the given triangle. Why don't we start by finding what theta is? So theta, the whole angle of the triangle needs to add up to pi, right? So we know 2 pi over 7 plus, so it's a 90-degree angle, so pi over 2 plus theta needs to equal pi. Let's disregard this, because that all needs to add up to pi, right? So to find what theta is, we're going to do theta is equal to pi minus 2 pi over 7 minus pi over 2, right? So it's essentially going to give us theta is equal to pi over 2 minus 2 pi over 7. So our theta is going to be equal to 3 pi over 14. So I'm going to take this, so 3 pi over 14. And so let's move on to the side lengths now and start by trying to find our y value. So we know our opposite in this case is, so sine of theta is equal to opposite over our hypotenuse, right? So sine of 2 pi over 7 is going to be equal to our opposite side of 5.3 over our hypotenuse of y, right? So by doing some algebra, we can get y times sine of 2 pi over 7 is equal to 5.3. So y is going to equal to 5.3 over sine 2 pi over 7, making y equal to 6.77895. Now we want to find our x value, right? So we can use either cosine or tangent. Let's go ahead and use tangent. So tangent of 2 pi over 7 is going to be equal to opposite over adjacent, right? In this case, our opposite is still at 5.3, and our adjacent is that 2 pi, our adjacent is our x. So to solve for x, we're going to have multiply the x over, so x tangent 2 pi over 7 is equal to 5.3, so x is equal to 5.3 divided by tangent of 2 pi over 7, which is equal to 4.2266. Remember, these are both in centimeters. And when we write our final answer, it wants us to round to 1 decimal place, so we're going to have 4.2 centimeters and 6.8 centimeters.